Good day guys! So today I will discuss about direct coupled transistor logic. So ano nga ba ang direct coupled transistor logic? Direct coupled transistor logic or Dctl is similar to resistor transistor logic or RTL, but the input transistor bases are connected directly to the collector outputs without any base resistor. So yung Dctl daw po is kaparehas lang siya sa RTL. Parang improvise lang siya ng RTL kasi alisin lang yung resistor doon sa base is magiging Dctl na siya kasi ang Dctl is yung kwan niya, yung collector outputs niya is directly connected to the base without base resistor. So consequently, Dctl gates have fewer components, are more economical, and are simpler to fabricate onto integrated circuits than RTL gates. So, ang unique characteristics daw ng Dctl is the transistor are also heavily overdriven. That is a good features in that it reduces the saturation voltage. So, ano nga ba ang ibig sabihin ng saturation? So, yung saturation po is yung na-discuss na din sa atin last sem is isa siya sa operation ng transistor. Yung saturation is the transistor acts like a short circuit. So, yung transistor is naka-on. Bali yung current niya is continuous lang from the collector to the emitter. So, reduces the saturation voltage of the output transistor, but it also slows the current down due to a high stored charge in the base. So, the operation of Dctl is the same operation of the RTL. When both the inputs are logic 0 or low, transistor operates in cutoff. So, yung cutoff din, isa rin siya sa operation ng transistor, which is the transistor acts like an open circuit or no current flows from collector to the emitter. And the output is logic 0, logic 1 or high. When any one of the inputs or both of the inputs are in logic 1 or high, the corresponding transistor operates in saturation and the output is logic 0 or low. Although Dctl is simpler than RTL, it is not popular because of the current hogging problem. So, yun na nga, ang current hogging is i-discuss ko mamaya sa disadvantage. So, doon muna tayo sa advantages. So, yung advantages ng Dctl is ease of manufacturing, lower power supply requirements, the fact that only one power supply voltage is used is a very convenient feature. Since low voltage are used, sometimes as low as 3 volts, power dissipation in both the resistor and the transistor is quite low. So, sa disadvantage na tayo. Ito na yung current hogging. Ano nga bang current hogging? So, ang current hogging is a condition in which the largest fraction of the current passes through one of the several parallel logic circuits because it has a lower resistance than the others. So, nagkakaroon ng current hogging dahil nga, 'di ba yung Dctl is wala siyang resistor na nakakonect sa base. Kaya yung current na pumapasok sa base is mataas. One of the most undesirable features of Dctl is what is commonly known as current hogging. And this phenomenon arises because of the spread in voltage base emitter on the various driven fan-out transistor. No two transistor will ever have identical inputs characteristics, and it is always desirable to use transistor with a small small production spread are possible on voltage-based emitter. So another disadvantage of Dctl is the crosstalk or the noise problem. In any high-speed system, pulses with fast rise times are likely to produce potential differences in the ground system, mainly because of the ground inductances. These voltages are likely to interfere with stable operation of the system. Dctl systems are very susceptible to this noise voltage because the operating and signal voltage are naturally low in this system. In several transistors on one end of the ground system are turned on, the resulting pulse generated in the ground system can supply a positive or negative pulse, depending on the polarity which can cause faulty turn on and turn off of the other transistor further down the ground system. So, yun po ang mga disadvantage ng Dctl. So, another disadvantage pa niya is lower speed operation. Tapos yun nga, noise immunity will be less. Kaya nga, may noise problem. Tapos, ito nga pala yung actual sample ng Dctl logic. Ito yung Leproscion computer. So, Leproscion computer was a second generation laboratory research transistor digital computer designed to explore direct coupled transistor logic. So, ginawa itong Leproscion computer para mag-investigate kung paano talaga gumagana ang direct coupled transistor logic. Tapos, Leproscion is a generally purpose stored program digital computer using more than 5,000 transistor storage for 1024 18-digit binary words is provided by a coincident current magnetic core memory requiring only 160 transistors. The logic of the computer is mechanized using direct coupled transistor logic circuitry. So, doon na tayo sa circuit ng Dctl. So, may iba-ibang klase ng circuit ang Dctl. May Dctl series gating. So, itong Dctl series gating is gumagamit siya ng NAND gate. So, di ba ang NAND gate, pag ang mga input niya is low, halimbawa nga itong input A, B, and C is low, the output will be high. Tapos kung ito naman lahat ng ito ay naka-high or naka-on, halimbawa ito A, B, C is high, the output will be low kasi nga NAND gate siya. The figure shows 3 transistors connected in series to form a NAND gate. Yan na nga, NAND gate ang ginamit dito for positive input signals A, B, and C. If any of the 3 transistors is off, the output voltage at D will be the supply voltage VCC. In the underloaded condition, the voltage at D will depend on the resistor RL and the VBE of the next stage transistor. So, punta na tayo sa another circuit ng Dctl is yun ang parallel gating. So, the figure shows a parallel Dctl gate which is really the previous considered inverter stage with 3 transistors having individual inputs instead of a single transistor. Obviously, this configuration is a NOR circuit. If any input is high on any of the 3 transistors, its collector will draw current through a load resistor causing the output to go low. So, dito naman sa parallel gating, ang ginamit niyang gate is NOR gate. So, di ba ang NOR gate, kabaliktaran siya ng OR gate, pag ma-operate lang ito pag ang lahat ng ito ay naka-off or walang voltage na pumapasok or mababa ang voltage, low voltage. Tapos, kung low tong A, B, and C, ang output nito is high. Pero kung may isa ditong high input, ang output nila is magiging low.